DeepSeek AI is revolutionizing the AI landscape with its Generative Reward Modeling, or GRM, which significantly outperforms traditional reward models. Unlike competitors like OpenAI's GPT-4 and Google's Gemini, GRM dynamically generates both rewards and critiques based on real-time input. This allows AI systems to handle complex, open-ended tasks with greater precision and adaptability. GRM also scales remarkably well. As more computational power is added, performance increases, making it ideal for dynamic, ever-changing environments. By eliminating the need for fixed, pre-programmed reward structures, GRM introduces a more flexible and generalist approach that can tackle a wide variety of real-world challenges. Its ability to create context-specific reward signals sets it apart, giving AI systems the capability to learn in a smarter, more efficient way. With this breakthrough, DeepSeek AI is establishing itself as a front-runner in next-generation AI development, setting a new gold standard for both adaptability and scalability. But what exactly is GRM? Why is it such a game-changer compared to older systems? Let's dive deeper. To understand the innovation of GRM, let's first look at how traditional reward models operate. These models guide AI learning by assigning a numerical score, a scalar value, to different outputs. This method is effective for straightforward tasks with clear-cut answers, like checking for grammar mistakes or solving a math equation. However, modern AI systems are increasingly asked to handle open-ended, subjective tasks, writing creative stories, having conversations, summarizing complex articles, offering tutoring, or responding empathetically in customer support. These tasks aren't black and white. There's no single correct answer. Quality is based on tone, clarity, creativity, depth, coherence, and emotional nuance. Scalar scoring just isn't enough here. It can't capture the richness or complexity of human communication. And as a result, these models often plateau when applied to real-world challenges that require more than just factual correctness. GRM changes this entire structure. Instead of using static scores generated by a pre-trained reward model, GRM generates textual critiques that explain the reasoning behind each evaluation. It doesn't just say whether a response is good or bad, it tells you why, using natural language tailored to the task at hand. For every input, GRM formulates a set of principles that define what a good response looks like for that particular case. Then, it evaluates multiple AI-generated outputs based on these principles, generating in-depth critiques for each one. Finally, it converts those critiques into scalar rewards. But now those scores are backed by context-aware reasoning. This means the model can adjust its evaluation style depending on the domain, whether it's legal writing, poetry, technical support, or storytelling. It's like having a critic that changes its standards depending on what it's reviewing, giving nuanced feedback instead of rigid numbers. Let's walk through how GRM functions step by step. First, the model receives a prompt and several possible AI-generated responses. Instead of using a static scoring formula, it begins by generating task-specific principles. These are dynamic and adapt to each prompt. For example, a science explanation might value accuracy and clarity, while a story might reward creativity and emotional depth. Next, it evaluates each response using those principles, creating a textual critique, a written review outlining the strengths and weaknesses of the response. These aren't just summaries. They're detailed and specific, often pointing out subtle elements that traditional reward models would overlook. Finally, GRM assigns a scalar reward to each response, but now it's a number grounded in well-reasoned analysis. This structured critique and reward process allows the AI to learn not just what's right or wrong, but how to improve and why certain outputs are better than others. Another area where GRM shines is in scalability. Most traditional systems don't get significantly better just by throwing more computing power at them. GRM does. It uses a clever method called sampling-based scaling. Instead of generating just one set of critiques, it produces many. These critiques are then filtered through a meta-reward model, which selects the highest quality ones. The model then learns from these best critiques, providing richer, more informative training signals. Think of it like gathering feedback from a panel of expert reviewers and then keeping only the best insights. This technique improves accuracy and robustness, ensuring that GRM doesn't just get faster with more resources, it gets smarter. The applications of GRM are vast. In content creation, for example, GRM can provide intelligent, context-aware feedback on articles, scripts, or ad copy. In education, it could act as a virtual tutor, giving students not just grades but detailed, meaningful feedback on their answers. Customer service bots could be trained to better understand tone, empathy, and user intent. AI tools for creative industries like music, art, or screenwriting could be guided by nuanced critique rather than simple metrics. Essentially, any industry where judgment, creativity, or communication are involved stands to benefit from GRM. It's no longer about just being correct, it's about being effective. There are still hurdles to overcome. GRM requires more computational power than traditional methods, especially when generating multiple critiques and running selection models. This can introduce latency, making it challenging for real-time applications. But the potential is massive. Researchers are already working on optimizing GRM for online reinforcement learning, where AI models learn and adapt continually based on real-time feedback. If this becomes scalable and efficient, we may be looking at a future where AI systems evolve more like humans, learning from thoughtful, tailored critique rather than simplistic ratings. DeepSeek AI's generative reward modeling is more than just an upgrade. It's a fundamental shift in how we train AI. By combining adaptive critique, task-specific principles, and scalable performance, GRM enables smarter, more responsive AI systems ready to tackle the real world. This isn't just the next step for DeepSeek. It's a potential blueprint for the future of all AI training. And if that future looks like GRM, it's going to be far more flexible, capable, and aligned with human values. If you're interested in more groundbreaking AI innovations like GRM, be sure to subscribe and check out our channel for full videos and insights into the future of intelligent systems.